Okay, so the first one, we're going to have two functions. The first one is h of x, and the second one is g of x. H is equal to 2x minus 5, and function g is equal to 2x squared plus 1. The composition that we are finding is h, big open circle, g of x. Okay? So remember when we were doing our multiplication of functions, I said to make sure that if we're multiplying, we need to have a closed, filled-in circle. That is because composition is an open circle. So the way we read this is h of g of x. Another way this can be written is h parentheses g of x on the inside. So reading left to right. H here would be our outside function. G here would be our inside function. And when we're doing the composition, our inside function plugs into our outside function. So I'm going to request that every time you see a composition written this way, so h of g, we rewrite it like this because it makes it easier to understand. So what this means, I am taking my entire g function, which is this 2x squared plus 1, and I'm plugging it in where the variable is in my outside function h. So this composition becomes 2 times 2x squared plus 1 minus 5. So I literally replaced my variable x with my inside function. And then from here, all I have to do is simplify. So that means I distribute this 2. This becomes 4x squared plus 2, and then minus 5. I can combine the 2 and the negative 5. And when I do, I get 4x squared minus 3. And then I'm done. That is what composition of functions is. We take one function and plug it into the other. And as before, the order that is written in here is the same order that we must follow here. Okay? Does that kind of make any more sense to those of you who actually looked at the notes before? A bit? Okay. So of course we're going to do some more examples, but this is it. This is pretty much the entire concept of composition of functions. So the next example I would like to do my first function is g of a, and my first function is 2a minus 4. My second function is h of a, and it is equal to 2a minus 2. So the only difference here is that instead of having a variable x, I have a variable a. The composition I would like to find is g of h of a. So g, open circle h, and then the a in parentheses. This a indicates that I'm leaving the variable in the final answer instead of replacing it with a number and solving. We will get to a point where we do replace it with a number and solve, though. So just like before, I want to rewrite this in the other notation for composition. G here is my outside function. H here is my inside function. H is going to get plugged into G. So in our other notation, I have G parentheses H of A. Again, indicating that H gets plugged into G. I always find this notation a little bit more helpful for the order in which I have to do things. That's why I insist that you rewrite it. These two notations, though, are equivalent to each other. So they mean the exact same thing. So what function is my inside function here? H, so the 2a minus 2, which means that 2a minus 2 is going to get plugged in to the variable a in my outside function g. So when I plug it in, this becomes 2 times the inside function 2a minus 2 and then minus 4. So I just replaced my variable with the inside function. And then from here, I just simplify. So this becomes 4a minus 4 minus 4. Combine the negative 4's together, and I get 4a minus 8. How do we feel about this? Not too shabby? Anybody still super duper confused? Because if you are, please tell me. No? You still want us to do that? You will do the odd number still, yes. But we're going to do a couple more examples before my computer dies. It is at 18%. We are good. I know, you're so excited. Huh? I know, I slacked today. Okay, leave me alone.
Wait, where is your turn?
It's back there somewhere.
So,
It's okay, I'll figure it out. Okay, let's go ahead and do another one. I have two functions, f and g. My f function is equal to x cubed minus 2x squared. My g function is equal to 2x plus 1. And I would like to find f of g of x. I know it looks like fog. I would, of course, first like to write this in my other notation. So Ariana, how would I rewrite this using the other notation? What's my outside function? So f, right? Okay, so that goes on the outside. Then what's my inside function, Ariana? So the g, and that goes on the inside. So that's how I rewrite my other notation. Just again, reaffirming that g plugs into f. The key here is that the inside function plugs into every variable present in the outside function. So that is very important here because my outside function f has two, oh no, I don't know what that is. Okay, my outside function f has two variables. So this is going to get plugged in twice. So my composition becomes the quantity 2x plus 1 cubed minus 2 times 2x plus 1 squared. I took 2x plus 1, which was my inside function, and replaced each of my x's with that inside function. So the hardest part here is that now I have to cube this, and I have to square that, which means I'm going to have to FOIL several times. So this is equivalent to 2x plus 1 times 2x plus 1 times 2x plus 1 minus 2 times 2x plus 1 times 2x plus 1. The cube indicates it's multiplied by itself 3 times. The square indicates it's multiplied by itself twice. So then I just start FOILing. Of course, we only do 2 at a time. So I'm going to work with those 2 first. When I FOIL this, I get 4x squared plus 2x plus 2x plus 1. Of course, I can simplify that into 4x squared plus 4x plus 1. And then I'm going to multiply that by the 2x plus 1 that's left. I did that same thing down here. Again, when I FOIL those 2 out, I'm going to get 4x squared plus 4x plus 1, just like we did down here. I'm going to FOIL this out again. Each one of these has to multiply into both of those. Make sure you keep that in mind. So 4x squared times 2x is 8x cubed. 4x squared times 1 is 4x squared. 4x times 2x is 8x squared. 4x times 1 is 4x. 1 times 2x is 2x. 1 times 1 is 1. Minus, and then we can distribute this 2 into everything over here. And then I just combine like terms. So this one is the worst it gets, truthfully. So this is the only x cubed that I have, so it's gonna say, once I use something, I cross it off to make sure I hit everything, because this is a really long problem. So then I can combine my x squares. I have a 4x squared, an 8x squared, and a negative 8x squared. 4 plus 8 is 12, minus 8 is 4. Then I can combine my x's, sorry. So 4x, 2x, and negative 8x. 4 plus 2 is 6, minus 8 is negative 2. And then I have a 1 and a negative 2, which is negative 1. So this becomes 8x cubed plus 4x squared minus 2x minus 1. It's too much. This is the hardest that it gets, or the most complex that it gets. Right? Oh, I know. It's because he didn't know what number it was because it ripped off. Yeah. Okay, do we understand the process here? I know this was a long problem and you don't enjoy it, but did we understand the process? Okay, so we're going to do an easier one, and then I'm going to introduce the second part to this lesson. Kind of. It's just an extra step, that's all. Okay. So on this example, I only have one function, and this is my f function, which is x plus 3. And the composition I would like to find is f of x. So we recognize that this means I'm taking my f function and plugging it into itself in place of the variable. So when I write it, I still have an outside function and I still have an inside function. So in the secondary notation, it would look like this. And then I'm taking f and plugging it in to f again. It's like inception. So this is equal to my x replaced with x plus 3 and then plus 3. So I just replaced my variable with my entire f function. It just so happened that I was plugging it into itself. So that became x plus 3 plus 3, which equals x plus 6. Are we all okay with that? So let's say, instead of doing f of x, I instead wanted to do f of 4. So that means I'm taking my composition and solving it at a specific x value or variable value. That means I take my answer and I replace the variable with whatever number that is, and I solve it. So then this becomes 4 plus 6, which equals 10. How do we feel about that? There are, just like before, 2 ways that we can solve compositions solved at specific values. This is the first way, where we simplify the composition first and then plug the value in. The second way is to plug the value in first, plug that answer into the outside function, and solve it that way. So we're going to do that using the same function, just so you can see how they compare. Yes, this is the other step I was talking about. So we're going to use the same function, and we're still going to solve it for, and we're still using the same f function. I should write that over here. So the first thing I would do is I would rewrite this in the other notation. So this is equal to f of 4. Where f of 4 is going to get plugged into my outside function f. Again, this is just an alternative solving the same problem we just did. If you like this way, follow this way. That is entirely your choice. This is just an alternate way. Some people like this way better, so that's why I teach it. Okay, so the first thing we do here is we solve this inside function. So my inside function here is f of 4, which means I take my f function and I plug 4 into it, and I get an answer. Then what I do is I take that number and I plug it in to whatever my outside function is. So then this becomes f of 7 because the function solved at 4 was equal to 7. And I do the same thing. So then I find f of 7. And it equals 10, which means my answer is matched, even though I approached it in different ways. We're going to try another one where I'm going to solve it this way because in my head this is the easiest way, but you're more than welcome to do all the composition work first and then plug in at the end. And then we are done because my computer is about to die. 10. It goes very, very quickly from 10. It does. I anticipate by the end of this problem I'm going to have a low battery warning. Okay, so let's do one more and then you are free to do your homework. So on this one I have two functions. I have the function g, which is equal to 4x, and I have the function h, which is equal to 2x minus 2. And I would like to find the composition g of h solved at -8. The first thing I do is rewrite this in the other notation. So this is g of h of -8. Oh, goodness. When we're doing something like this, I need to solve my inside function first, which means I need to find what h of -8 is equal to. So I go to my h function, and then I plug in -8, and we see what answer we get. So that means I get 2 times -8 minus 2. I know 2 times -8 is -16. Minus 2 is -18. So formally, I can write that h of -8 is equal to -18. Are we all okay there? Are we all okay? So then I take that -18 and I replace h of -8 with it. And I get g of -18, which means I go to my g function and I plug in -18 for g. And I get my answer. What answer do we get? -72. So g of h of -8 is equal to -72. How do we feel about that? Anybody super duper confused? Because if you are, please tell me. No, you could do it this way where you do the composition first and simplify it, and then at the end plug the value in. That's entirely your choice. Just some people like this way better. And honestly, I think it takes a few less steps, but that's just me. Whatever way you're comfortable with is the way I want you to do it. So from here on out, it's just homework time. Tomorrow, we're going to do inverse functions. And then on Thursday, you're going to have a quiz over everything from Unit 6. So function notation, operations of functions, composite functions, and then tomorrow's inverse functions. All the functions. We put the fun in function.
Not really.